Hello and welcome, my dear grade 10 elite students, for today's session. This is in continuation with the last video that was put on my channel. So right now I'm working on part 2. So this is the second video of the series, which has the multiple choice questions that are going to help you for your tomorrow's exam. So stay glued with me till the end and make sure you like, share and subscribe to the channel so that it serves as a motivation for me to make more and more content for you. You can also follow our Instagram handle, which is there on my channel page for more such content. Let's do question number 14. This is on simplifying complex fractions. So in question 16, 17, 18 and 19, the four kind of questions that you see here are complex fractions. Complex fraction is a fraction which has the numerator also as fraction and denominator also in fraction. So this is actually a rational expression with two a numerator and denominator being fractions. So such are called complex fractions. Now we are going to solve and simplify them one by one, and the concept that we are going to use is the concept of LCM or LCD. That means we are going to make the denominators common. So if you see here, the denominator and numerator is x minus 3 and the denominator in the other part of the numerator is this. So we can make it equal by taking the LCM or LCD. That will be x square minus 9. Similarly, we can do the same in the denominator also. We have to make the denominators equal, and sometimes when these are different, like this question x plus 5 x minus 6, the LCM would be the product of them. So we are going to multiply. Then we take the simplification of the numerators, denominators, use the reciprocal and simplify. So let me show you the steps one by one for these questions in the next slide. So let's do question 16. As I told you, here we will be taking LCM or LCD. So it is going to be x square minus 9, which can also be written using the algebraic identity a square minus b square as a plus b multiplied with a minus b. This one. So we are going to now make the denominators equal. So here I take the LCM as x square minus 9. Here also I take the LCM as x square minus 9, and we are dividing and multiplying with the same value so that it will cancel in the factors. So now you apply the distributive property. So distribute this over here, this over here, this over here and this over here. So what will you get? 2 divided with x minus 3 multiplied with x plus 3 and x minus 3. So x minus 3 khalas, x plus 3 is left. Similarly in the second one, this and this is khalas, so 3x is left. Divided by, again x plus 3 khalas, so we are left with 3 to the power 3 multiplied with x minus 3 minus 4x. Now just apply the distributive property and simplify. So 2 multiplied with x is 2x plus 3x, that's gonna give you 2x plus 3x as 5x, and you have 2 multiplied with 3, that's gonna give you a 6 here. In the denominator, 3x minus 4x is going to give you minus x, and minus 3 with 3 is going to give you minus 9. So this is how you simplify. Again, you do the same steps for questions 18, 17 and the last one as well. You are going to take the LCD, then apply the distributive property, multiply them term wise one by one, simplify, collect the like terms, multiply and get your answer. As I told you in the last slide, when the two values are different, their product is the LCM or the LCD. So LCD is going to be x plus 5 multiplied with x minus 3. You multiply numerator denominator with it, cancel the common factors, simplify, use distributive property and get your answer. You do the same method for this question as well. Now we are going to graph reciprocal functions. This is lesson 7.3 that we are moving on to. And for graphing the function, we will be using some concepts which are related to the transformations of the reciprocal function. So all of these four questions that you see are actually transformations of fx equal to 1 by x. So 1 by x is the reciprocal function. If you transform it, so when I say transform, it means three types of transformations. I just want to recall for you, those who have forgotten. We are going to talk about translations that can be vertical and horizontal. We are going to talk about reflections, which can be along the x and y axis, and we will also talk about dilations where you multiply with a number. So in these four questions that you see, we have questions where we are translating left or right, that means horizontal translation, or we are translating up and down, that means vertical translation, or we are taking a reflection from any of the x or the y axis. Also, we are going to use our knowledge of horizontal asymptote, that is, in case you have forgotten, I will remind for you, asymptote is that line or that part of the graph or that equation where the graph is nearly touching but not exactly touching. So let's see the steps to solve them now one by one. So the first question, that is question 13, I'm going to compare it with fx equal to 1 over x minus h plus k. So what is the value of h here? If you compare x plus 3 with x minus h, your h is minus 3, therefore the graph is going to move left 3 units, okay? Then the vertical asymptote is going to be at this point, which is x equal to h or x equal to minus 3. Okay, then we compare the value of k, minus 3 with k, so k is going to be minus 3. So the graph is translated down and the horizontal asymptote is at this value of k. So remember, your value of h is going to give you the vertical asymptote, your value of k is going to give you the horizontal asymptote. Okay, and asymptote, as I have already told you, is the line or the equation where the graph is nearly touching. So the domain is going to be the set of all x where x is not equal to minus 3. Remember, asymptote cannot be a part of the domain. So similarly, in range, we are removing these points. We are removing x equal to minus 3 and fx equal to minus 3. We don't need these points because at the asymptote, the function is not well defined. Also, remember, domain is input coming from the x-axis, range is coming from the y-axis. So this is your graph of graphical function y equal to 1 by x, and we have done the translation, that is, we have moved the graph by 3 units and we have translated it down by 3 units. So this is the graph that you get. Okay, again you compare fx equal to 1 over x minus h plus k with this. So your h is going to be minus 5, your k is going to be minus 6, and now there is a negative sign also. That means the value of a, which is going to help you with the dilation or reflection, to be very precise, is going to give you the value of a as minus 1. That means the graph is going to be reflected in the x-axis. So if this is the x-axis, what is up is going to come down, what is down is going to come up. H and K we have already discussed, so that means the vertical asymptote is at x equal to minus 5. The horizontal asymptote is at fx equal to minus 6. So the domain is going to be the set of all x such that x is not equal to minus 5, and the range is going to be the set of all fx such that fx is not equal to minus 6. So these are the domain and range. In a similar way, you can do question 15 and 16. The same concept will be used, and for domain and range, remember, we are removing the point where you have the vertical and horizontal asymptote. Okay, let's solve now questions on lesson 7-5 variation. So there are 4 types of variation. I hope you know about them. We have the direct variation, we have the joint variation, we have the inverse variation, and we have the combined variation. So in direct variation, if there are two variables y and x, then they are going to vary directly. So increase in one will lead to increase in another. In inverse variation, the opposite will happen. So if one will increase, the other will decrease. So y is proportional to the reciprocal of x. Okay, and then there is joint and combined variation also. We are going to discuss about them. So from questions 26 to 37, we are going to be using this concept. We have to say which one of the 4 categories is each part for the given variable. So for example, question 26, c is equal to 12m. The variable which is given is, the given variable is c. So you have to say for c whether it is direct variation or joint variation or inverse variation or combined variation, and then you also have to find the constant of variation, which is generally denoted by k. So let's solve these questions in the next slide. So these are the following questions for question 26. C is equal to 12m, where the variable C you have to check whether it is direct, inverse, joint or combined. So here y varies directly as x. See, one variable is C, one other variable is m. So C is given to be 12 times m. Therefore, there is a non-zero constant k. The value of k is definitely 12 here. So that C varies directly as m. So I'm able to write C is equal to 12m, or y, which is representing the variable C, is equal to k times x. So when you are able to write like this, you say y is varying directly as x. So here C is varying directly as m. Next is P equal to 4 by Q. Now if you see, Q is in the denominator, so this cannot be a direct variation. We can say P is varying as K over Q. So that means P and Q are inversely related. So P varies inversely as 1 by Q. So this is a question on inverse variation. What is the value of K? If you compare the question P equal to this with P equal to K over X, you know that the value of K is going to be 4. So the value of the constant here is 4, and Y is varying inversely as X, because you have the non-zero constant K equal to 4, such that you can write Y is equal to K over X. So this is inverse variation. Next is joint variation, where you see product. So whenever you have joint variation, you will be able to see the product of two variables. So you see B is multiplied with H, so Y is varying jointly as X and Z. If there is a non-zero constant K such that Y is equal to K times XZ. So what is the value of K here? It is 1 by 2. This is the constant of variation, and A is varying as jointly product of B and H. Okay, next is RW is equal to 15. Here you have to say for the variable R. So you are going to calculate the value of R. R will be 15 over W. That means it is coming in the denominator. So this case is going to be of inverse variation, where Y varies inversely as W, and there is a constant K equal to 15, which is there. Okay, next is Y equal to 2 RGT. You have to say for Y. So Y, you can see, is the product of 2 times R times G times T. So many variables are multiplied with each other. So therefore this is a joint variation, where the value of K is definitely the number 2. So K is 2, and this is a joint variation. Similarly, question 31 is a question on direct variation. You have to say for the variable f. So you can see f is directly related to m. The value of k is 5280. Okay. Again, then y is directly related to d. The value of k is 0.2. Here for question 33, y varies inversely as x if there is some constant k such that xy is equal to k, or y is equal to k over x. So in this case, z varies inversely as v, and the constant is given to be minus 25. Okay, so here you have to say for z, so you can write z as minus 25 over v, just to compare, and then you see v comes in the denominator, so that is the reason why it's an inverse variation. Next is y varies jointly as x and z. This is very easy to see, because T is varying directly as the product of R and H. Wherever there is product, it is going to be joint variation. The value of k is 16. Here R is varying inversely as the proportion of W. The value of K is 8. Next one, B is varying directly as X. Now this is a tricky question. So if you see B is equal to A by 3, there is a denominator, but the number is there. There is no variable. Variable is coming on the top only. So when it is like this, it will be B varies directly with A, and the value of K is going to be this number 1 by 3. So that's your constant of proportionality. Let's solve some more questions on lesson 7.5 variation. These are going to be also solved in a similar way on direct, joint, inverse and combined variation. For the given variable, you have to see which is the one which is going to give you the correct answer, and also you have to name the constant of variation. That is, give the value of constant of variation k. Okay, so let's do these questions 38 to 49 one by one in the next slide. Okay, so let's solve question 38. X over y is equal to 2.75. You have to say for this question, for x, what is the variation? Is it direct, joint, inverse, or combined variation? So here x can be written as 2.75y. That means x is equal to ky, where k is the value 2.75. So this is a question on direct variation because y varies directly as x, and you have the non-zero integer k equal to 2.75, which is giving you the constant here. Then f multiplied with g is equal to minus 2. You have to say for f. So you will calculate the value of f as minus 2 over g. And here if you see, f and g are in the numerator and denominator. So f is varying inversely as g. This is a question on inverse variation. And the value of k is minus 2. That's the constant. Then a is equal to 3 multiplied with bc. You have to say for a. So you see a is varying jointly as the product of b and c. So this is a question on joint variation, and your value of k is 3. Then comes question 41, where 10 is equal to x multiplied with y square over z. You have to say for x. So I'm going to rearrange the equation in this manner. 10 multiplied with z, I'm doing cross multiplication, divided by y square. So now if you see, there are three variables x, y and z. So x is varying directly as z, however x is varying inversely as y square. So there is a case of both of them. That means this is a question on combined variation. Why combined variation? Because here both direct and inverse is there together in the same question. Therefore, it is a question on combined variation, and your value of k is definitely 10. Next, similarly, you can do question 42, 43 and so on. Okay, so that brings us to the end of this video. The last video that will come on my channel will be around 8 p.m. for today. So stay glued till the end and make sure you like, share and subscribe to the channel. This is Mr. Chika signing off from this video, and see you in my next video, which is going to be the last video, especially for grade 10 elite students on your special request. And all the very best to all of you for tomorrow's exam.